Hi and welcome. This time around we have a bit of a complicated project. I have to make a dispenser for these guys right here, and these have some medical use. I'm not sure what. They're a 2.5 millimeter, 2.4 millimeter, something like that, hollow tube, stainless tube with the end with a stainless tip on. And this is one that hasn't been welded on yet. So you pick these up as an assembly. The tip gets pressed on by a human being first, and then this whole assembly, this piece gets picked up and placed into a set of V-blocks that will go on a laser welder that will then rotate this part and weld this tip on right here. I should have some welded ones here as well. Let's see. Yep, there's one that's been welded on. Hopefully you can see that. So it's a little bit of a challenge because we only want one of these. We want them oriented the same way each time you pick them up. We want the robot arm to be able to pick it up in the same spot so that when it sets it down, it knows roughly where it is relative to where it's going to be seated. So that's a little bit of a challenge, and we're going to give it a shot. For an actuator here, I have a rotary solenoid. You might not have seen one of these before. It's also called a rotary actuator. And this one will travel through 45 degrees, which isn't very far. I'm thinking about a design like a toothpick dispenser and something, a sphere, you know, a cylinder that rotates with a slot in it that will fit just one of these, and they'll be dispensed down into one. It'll rotate and dispense it out. And because it only travels 45 degrees, and I want a travel of about 180 degrees, a little 120 is probably fine. I've got a set of gears here that'll set up the gear ratio 4:1 so that I can get that extra oomph. Now this thing is pretty powerful, this solenoid, and I do have a concern that it's actually going to throw these things as they rotate around rather than dispense them. So we'll have to address that when we come to it. This is a solid state relay, and that is a diode to stop the inductive kickback from this thing. It'll be controlled by a GPI from the robot itself, the robot arm, that they can program so that it'll tell it to dispense the next one of these needles, or whatever they actually are, when the previous one's done. So let's go see if we can find some material first. I don't know if you can see this, but look at that. It's like 1/8 of an inch too long to fit in here. But this guy's got some other tricks. You can remove this fence. There you go. And you can use it like a normal bandsaw. You can lock the blade in place, or I can put an auxiliary fence down here, which might be what I'm going to do. So I've put some layout lines on this part, and I'm not sure, it's not going to cut all the way to the end here. I'll have to do that manually. But I put an auxiliary fence just with a piece of this tooling plate that was cut by Industrial Metal Supply, which does a really good job. They do a really good job of keeping things straight. So the only thing I have to worry about is that the saw blade relative to the table, which is what I used as my reference, isn't exactly square. So I'm going to have to leave a little extra material that I'll have to take off after. The beauty of this saw is as it cuts in, it actually pushes the work into the fence, which is really handy. If you had the clamping from the other side, like you're pushing up against something, then all your force would be pushing, trying to undo the clamp. That's not the case with this saw. And I have been sort of jealous of Tom Lipton's fence design that has a piece here that has the movable piece pushing up against it, because it gives you a lot of extra ability, which I've thought about adding a specific fence like that or a clamping system like that. However, it doesn't have the advantage of pushing the part into the fence like I was just explaining. This one does. To get this started, I'm going to need both hands, so I'll bring it back. Well, the cut ended a little bit sooner than I thought because it ran up against the arm there. Forgot about that bit. Should have had the work off to this side. Here's another way to use this guy. So you can use it as a regular bandsaw if you do it this way, and I'm almost about to make the same mistake again. I got to rotate this guy around. But ooh, it's still not going to clear. Look at that. Anyways, you take the back of this guy here and you slide this forward and lock it off. That holds the blade in place so it can't go back or forward. And then you just use it like a regular bandsaw. However, your throat distance is somewhat smaller than many bandsaws, so that's going to be a problem on this. This is a very coarse blade, so it cuts really quickly, but it's probably not the best choice. You're probably barely getting 2 teeth engaged in this 1/2 inch material on this. So probably would be better to go to a finer pitch blade, but we've cut some other stuff and it seems to work, and it's aluminum, so hopefully it won't break a tooth. So I blew it on the layout lines on this side, didn't notice the holes that are pre-drilled there, but fortunately there's plenty of material here. That could have been fatal. Unbelievably stupid there. And it's funny, that's where I ran out of cutting length, right on my line, so that's convenient. So I've got room over here. We're going to cut out the second piece and we're just going to go. I suspect there'll be too much vibration for you to see this clearly. If you're wondering what to do with all this scrap, normally you'd say, oh, toss it out. But here's the thing. This is tooling plate, so that means that this thickness is very, very consistent across its entire length. And you can use these for spacer blocks. They're perfectly functional. You gotta, of course, deburr the edges. Let me just show you how close they are. Okay, so here's just an average piece of tooling plate and one of the cut-off scraps. So let's take a look at this. So here we are, 0.5141. Let's go to the other end here. 0.5141. That's within a tenth end to end. I'd have a hell of a time on the milling machine trying to face something and keep that tolerance. 0.5141, that's the other side now. 0.5141 again. Half a tenth difference in thickness. So you can see why keeping these scraps is really useful. If you need to space something up consistently, this stuff makes really great material, and they've done a lot of the work for you. That's why I can't throw it out very easily, even though this scrap seems like, I mean, this is a pretty big piece, but even the small pieces I keep, because I use them even when I'm welding. If I want to set some stuff consistently spaced off the table, that's what I use. Remember when I talked about my hopes and dreams for what would happen here? Well, even in aluminum, look at that, teeth missing. So I did the stupid thing so you don't have to. So lesson learned, swap your blade out. There's broken teeth all over the place on this poor thing. Oh, that was stupid. I did cut some 1/4 inch material off camera. 1/4 inch, you get one tooth per cut. That is obviously inadequate. This is a variable pitch blade, fairly expensive. That was really stupid. 50 bucks out the door. Here's the product of my stupidity. And this is the 3/4 inch bandsaw blade, $50 that I aced a bunch of teeth off of, all over the place, unfortunately. And I might have done it today, I might have done it a different day, don't know, but it wasn't cutting well at the end, so I'm guessing it was today. I'm still gonna save this because this is some pretty handy spring steel, and if you need spring steel in a pinch, this is pretty good. So yeah, my problem is I can't get rid of anything if I think I can find a use for it. That's a big problem. All right, next up, we got to get these plates to size, and right now they're sort of rough cut. About a 1/2 inch over, 1/4 inch over on all dimensions. Processing plates is kind of a pain in the butt, especially if you want them to match. So what I'm thinking about doing is I'm going to drill and tap some holes in these plates and join them together so that they'll be exactly the same size the whole time I'm processing. Because all the holes that go through, like on the 1/2 inch side plates that go through one side, have to meet up exactly on the other side. So if I process them together, then the holes will at least be collinear. So that's a good idea, I think. The bigger plate can't fit that in the vice jaw, so we'll have to do something else for that. I've shown several techniques in the past, and we'll probably use one of those. But in the meantime, I'm just going to drill and tap some holes in these guys to mate these two pairs together, these 2 1/4 inch plates and the 2 1/2 inch plates. All right, so we're going to put the 4 holes in these guys. This is the tapping drill. I center punched all 4 holes first, and they're roughly placed. They don't have to be precise or anything. They look roughly symmetrical, which is most important because they're non-functional holes in the final product. I don't think it'll bother the customer at all. I could do the can't twist clamp thing, but every once in a while with the can't twist, as you're tight, things kind of twist a little, shift a little as they're going. I can't twist and they twist right. That's very funny. But they tend to shift a little, so rather than risk that happening once I start processing, I'm just going to screw these guys together with 4 screws. And we're just going to use a manual drill motor here. Those are the tap drill size. So then I'm going to detach these two plates and I'm going to do the through holes on these guys and tap the bottom. All right, so we're going to power tap these guys. I have had problems in the past with breaking small taps, and I think part of the problem was that I didn't have this perpendicular, so I checked to make sure this was fairly perpendicular. That went very nicely. Can increase the exit speed. We'll double that. Looking good. So the 1/4-inch plate's obviously the easy one of the two. The 1/2-inch plate will be interesting. 4 holes for tap that quickly. Now we'll move on to the 1/2-inch plate. By the way, I didn't get a Kurt vise just for this. It's where I store the Kurt vise for my mill. The second one when I'm not using it. No problem. Gotta tell you, that's a lot easier than hand tapping. Gotta make sure to remove all the chips because chip clogging is what breaks taps. Also not being vertical, obviously. So I'm just gonna connect these guys together. That way when I machine them, I probably should have used a washer with these. Come to think of it, I'm gonna go grab a washer. This might seem like a lot of work to go through, especially since clamps would work. I just thought it would end up have a better end result. These need to fit pretty closely together. There we go, that's one assembly now. We can drill and machine this part. And now for number 2. And I didn't think about not having the right length screw size for this. I may not have the right screws. That is very funny. This is 1/4 inch, so 1/2-inch screws would be a little bit long. 3/8 would probably be good. Should have probably done 1032 instead of 1024. Get more threads biting, but it's not a lot of force, so hopefully this will be all right. So 1/2-inch screws with a washer means they shouldn't go all the way through. One problem with hand drilling screws for tapping, especially with close fit, is that you may not get them lined up, but you may go in at an angle, because it's harder with a hand drill to be vertical. I used to have a drill press, but I got rid of it to make room for the milling machine and all the other equipment. I really don't have room for a drill press, so it's definitely a sacrifice. It is nice to be able to make sure you're drilling perpendicular to the material, which I obviously did not do extremely well with the hand drill. Probably should just use the milling machine. I always told myself I would, but it takes a little bit longer to set up that way. Well, the best laid plans, and all that, because remember I said I can't twist clamps, sometimes slip? Well, when I was drilling, they slipped because you can see these edges were saw cut edges and they were, it's sort of a blade, sort of like a table saw that cuts these, except it's top down, sort of like a radial arm saw. These are very accurate by Industrial Metal Supply. Anyways, now there's like almost a 1/16 of an inch gap on this side and flush on this side. So yeah, they slipped quite a bit. Anyways, we're going to straighten them up. Fortunately, I think I have enough material to clean these up. So I'm just going to go in far enough to clean up one side. There we go. Call that my X0. Okay. That's one side. Now we're going to rotate 90 and put this against the back because it's flattest. And we're just doing the same thing on this side. You can tell it's quite a ways off too. I hope I have enough spare material. That gives me 2 square sides, which means now I can just measure against these 2 sides and get my final dimensions. Right on the money. It's in a 1/2,000th, at least according to a caliper, which you don't trust to that accuracy. Last step is this side, which is still rough. That's why I've got the aluminum welding rod in there. Rotate it this way. These sides are parallel, this side's square. This is the last side, and we'll get this final dimension at the same time. Right on the money. And we're good with this part. So I think it was an interesting idea, but I don't think it succeeded exactly because couldn't even use one of the screws because it didn't line up. But the rest of it now is all dimension. Both parts are identical, and that should be good. So this one almost fits in the vise, and by almost I mean the long way won't fit in the vise, at least with the vise jaw configuration like this. So we're going to adjust it to make this work. But I should be able to get both these 2 sides parallel by doing this side and then just going to the other side, which you won't be able to see, and do that side and do the final dimension on that length there, and then come back and do these other 2 sides once I reconfigure the jaws. So I'm going to start with the side you can't see, and I'm just going to clean it up. Then we'll come over here and use this one to do final dimensioning, which will make these asymmetrical, these holes, but they were only roughly symmetrical to begin with. Right on the money. It's about 1/1000th taper in it, but that'll be okay. All right, so now I can't fit these lengths between the jaws because that exceeds the capacity. I think these have a 9-inch, this has a 9-inch capacity. Heck, I'm already almost all the way back as it is. But there's another way using the Kurt vise if you want to hold a part like this, and I'm going to do it just to show you. So I've got to take off my cover for the back of the vise. Mutual Kim made me this, and I ended up having to replace the leather because the other stuff, the Naga Beast material, was getting hot chips melted into it, and it eventually got trashed. So this has to come off, can't use that. Then, that's right, it's next size up, isn't it? And I'm going to be 100% honest with you, this will be the first time I've ever held anything like this as well. So I'm kind of interested on multiple levels here. So they actually have mounting holes on the back where the vise jaws can sit on the back. Now this is not as good because instead of pushing the jaw into the fixed jaw here, you know, instead of pushing it into a flat surface, it's trying to pull it away. So the only strength you've got is screws holding it. And these may be 1/2-inch bolts that are hardened, but that if you were doing something super critical, this may not be the best solution. To hold this flat plate material, I think this will be okay. And same goes for this other guy here. Which this is going to let me hold the 12-inch plate as well, it looks like. I think that's about 12 inches. I guess we'll see. Fortunately, the 12-inch plate, the dimensions really don't matter at all. That was an arbitrary size choice. Good fit. All right, so we start by cleaning up this. Actually, I can do it the same way I did the last one. So I'll do the far side first that you can't see, and then I'll come back and do this side. Oh, but will I have enough? Yeah, I should have enough travel too, I think. If I can get off the end back there. Let's see. Yee-hoo-hoo-hoo-hoo. Is that going to make it? Boy, talk about barely. I think the high point is just barely past it. We will see. If it doesn't, I can always move the head forward, the whole mill head forward. I just realized I won't be able to do the 12-inch piece unless I want to do it multiple passes, because there's not enough travel in this length here. I'd need 3 more inches, and I don't think I have 12-inch travel. Nope. I'm like 1.5 inches short. All right, but that's one side. Holy cow. I didn't realize how much material has to come off of here. I made this massively oversized. I think I might take this guy over to the bandsaw. This basically needs almost 6/10 of an inch removed. Rather than use the milling cutter, I'm going to take it over the bandsaw and remove some more material, and I'll be right back. So I cut off this much material. I guess that probably sped things up quite a bit, plus saved the life of my milling cutter. And we're there.